I'm Frank, a Specialist Solutions Architect working here in security at AWS. During the course of my work, I come across customers that struggle with implementing effective incident response. Today, I'm going to talk about how you can proactively prepare for incident response. The point I'm going to impress upon you is you can effectively respond to incidents with the right preparation. I'll talk about how you can best prepare yourselves and your organization and point you to some resources that can assist you with this. Incident response is important because there are real benefits to your business in doing it well. I'll give you some examples in a moment. Interestingly though, customers often struggle to do it effectively or at all. I'll lace this session with some real-world examples from my experience and how we work to improve those. I'm going to frame building effective IR capabilities in 4 phases during this session. I'll also give you a demonstration of how you can start with some simple automations and incident handling right in the AWS console. Finally, I'll give you a brief recap and some action items. So whether we call them unplanned service interruptions, incidents, or something else, definitions are helpful. This definition is taken from the NIST glossary for the word incident. There are certainly other definitions. I'm going to focus on this part of a larger definition as it is relevant to us and to this session. Think of your regular workspace for a moment. Imagine that as you're sitting there working, you start getting notifications. The message is the same. People are seeing application functionality failing for some application users, but not all. Soon after, you start receiving calls from developers saying that the new features that they recently released do not appear to be available to customers. So within the space of about 5 minutes, you now have 2 or more or less incidents occurring. You need to understand what the problems are and how you're going to fix them. Thankfully for you though, this is actually not the beginning of the story. That beginning took place several months back. In a moment, let's go back there and pick up the real beginning of this story. We've got to start somewhere, whether it was 2 months ago or now, and this proverb sums it up nicely. It's never too late. Before we go back to the start of this story, I want to talk about why this process is important. Good outcomes usually start with good planning and preparation. This is definitely not something we want to leave to luck. Having effective incident response plans confers real financial, reputational, regulatory, and operational benefit upon your organization. I want to take a moment to cover some of these benefits now. Organizations that formed IR teams and tested incident response plans saw an average total cost of a data breach that was 42% less than organizations that didn't. Organizations that are further along their cloud maturity journey were able to identify and contain breaches 77 days faster than those in earlier stages of modernization. Okay, it's time to get into the core of this session, so let's do it. As I mentioned earlier, there are 4 phases I'm going to cover, and each is critical in preparing your teams and organization for effective incident response. 1. Plan and prepare. 2. Simulate and test. 3. Undertake continuous improvement and retrospective activities. 4. Automate. As you'd expect, companies do have challenges in each of these areas, and I'll mention some examples at each of these phases and discuss how we met those challenges. Remember though, while I'll be talking about some specific services and architectures, it's the underlying concepts and principles that are important, and these are what I'd ask you to please focus your attention on. First up, planning and preparation. An example. For one customer, the planning went as far as having engineers on call on a roster. While the customer had not experienced an outage, they didn't know where to start in defining what type of incidents mattered to them. So while they worked internally to conduct an informal risk assessment, we worked with them to establish what were the most common findings they were observing in AWS Security Hub from integrated services. AWS Security Hub is a cloud security posture management service that performs security best practice checks, aggregates alerts, and enables automated remediation. The customer grouped those findings, and we then provided guidance on how to create playbooks that would guide their responders through an incident specifically for those finding types. Then we also pointed them to the AWS Samples GitHub page, where they then downloaded and customized 4 playbook templates that exist already, and that you also have access to. Those playbooks provided templates for dealing with unintended access to Amazon S3, AWS IAM credential compromise, responding to DDoS attacks, and ransomware. That repository is named AWS Incident Response Playbooks, and the content is available for you to access, fork, and/or download. Use these resources to start building your own playbooks. Defining both the incident you're addressing and the response you're going to take are a big part of setting yourself up for success. Of all the things that could go horribly wrong, what actually will? The fact is, you don't know, nor do I. But you do need to enumerate a list of real risks to your business and the services you provide to your customers. What preventative and responsive measures will you take? Some customers undertake full-blown risk assessments, still others map out risks with informal processes similar to risk assessments. Ideally, this is informed by a threat modeling exercise, and you can find more information about threat modeling in our security blog. Once you've defined the incident, you must map out how you will respond to it. To continue the story from earlier, you have an intermittently failing application and are fielding calls from your team, and in every system administrator's favorite scenario, the failures don't have an obvious pattern. They're intermittent, which means any theories you've got about cause can't be validated. Why does the application provide full functionality to some users but not to others? Why is the new functionality not available? 2 months before this incident, you went through a process of identifying what risks there were to application availability. You came up with a group of potential issues, including rolling out unapproved code, incorrectly configured resources, such as security groups, and unapproved resources and configurations. A key component of your application is that your front-end web servers use a pre-approved ARMY. So, one scenario that you covered was that a non-approved image is used in your launch template tied to your EC2 auto-scaling group. A launch template, by the way, is an Amazon EC2 instance configuration template that an auto-scaling group references when launching instances. An auto-scaling group allows you to provide more or less capacity to your application based on user demand. Let's look at defining the incident and response more closely. Before you start building capability, you need to understand what an incident is, what it means to you, and how you're going to respond to it. You need to define the characteristics of each incident you want to be able to respond to. What resources are involved? What are the indicators that will be used to determine an incident has occurred? Where, for example, in which AWS service, do you expect those indicators to be detected? If those indicators include metrics, what is the threshold beyond which you must act? Back to our story, and just a reminder, though I'm using specific resource types and architectures, these are just to make a point. It's the underlying principles and concepts that are important. Let's break out part of your architecture. Your approved ARMY includes software libraries that your application depends on, as well as pre-approved packages that have been scanned for open CVEs. So for you, the use of a non-approved ARMY is definitely an incident worthy of attention. So you can define your incident as the use of an unapproved ARMY. You've created an AWS config rule to monitor for this. AWS config is a service that monitors the configuration of your resources in AWS, such as EC2 instances. If an unapproved ARMY is used, then AWS config will evaluate the EC2 instance using that ARMY as non-compliant. This is going to be your indicator that an incident has occurred. There may be others, such as the instance returning HTTP 4xx or 5xx messages to the application load balancer because the application is not working on the instance due to the missing libraries, or maybe even that the application is stopping the web server service from starting. So for this incident, we now know the involved resources include EC2 instances and armies and application load balancers. The metrics include HTTP 4XX and or 5XX via the application load balancer metrics and non-compliant findings from AWS config for the approved army by tag AWS manage config rule. If we see that non-compliant rule evaluation, we know there's definitely a problem. If we see the 5XX and 4XX metrics increasing only, there might be a problem, but not this one. We'd need to investigate further. Once you're able to clearly describe what constitutes an incident, then you need to be able to describe very clearly what the responsive steps are for that incident. This is where your playbook comes in, and I'll get to that in a moment. It's likely that regardless of the incident type, your high-level steps are going to look like this. Page responders. Confirm that something is actually happening. Inform stakeholders. Execute resolution steps. Validate resolution. Conduct cleanup and post-incident activities. An IR plan outlines your strategy for handling incident response. It will list roles, accountabilities, and your high-level approach to incident response across the phases of dealing with an incident. Think about the NIST recommendations for handling computer security incidents: preparation, detection and analysis, containment, eradication and recovery. Playbooks outline the specific steps you, normally a human responder, will take to resolve an incident, with reference to the phases outlined in the plan. Existing resources like the AWS Incident Response Playbook repository in the GitHub AWS Samples location can be a really helpful starting point. The details in your playbook will change depending on the type of incident, the resources involved, and the application those resources support. So, for example, in the non-approved army situation, your playbook may include steps like the following. Firstly, you want to get your responders notified and have them acknowledge so you know someone is working on this. Then, they want to verify that the metrics and indicators you expect to see are actually present. I outlined some examples of those a moment ago. Then, identify the exact instances involved. If they are part of an auto-scaling group, you want to check the launch template associated to the auto-scaling group and ensure the correct army is referenced. If it's not, fix it. For example, create a new version of the launch template. If it is, check CloudTrail to see if the instance was manually registered to the relevant target group and who did that. Now, if you've created a new version of your launch template, you might be looking at the instances currently registered to it and see that nothing's happening. You're either going to need to terminate the offending instances or deregister them. Think about whether your response includes isolating the offending instance for further investigation. So let's quickly take stock. We've covered plan and prepare, next is simulate and test. Another customer example. I've also worked with customers that had playbooks but had never tested them. I'll talk about this in a moment, but we did encourage the customer to first have their responders perform each of the steps in the playbooks. Could they be executed successfully? Once they could, and any problems were fixed, then it was time to simulate an event and stress test the procedures. The simulation of a failure or event allows you to test systems, processes, and team responses. The purpose is to actually perform the actions the team would perform as if an exceptional event happened. These should be conducted regularly so that your team builds muscle memory on how to respond. There's more information in our well-architected documentation. You want to test your plans and playbooks, and there are a number of advantages to doing so. You can potentially identify ahead of time if the steps in your playbook actually can be carried out and completed the way you expect them to, and you'll be able to further refine the playbook based on the results you obtain from testing. The people responding to incidents will become more familiar with the steps in the playbooks and the actions required to complete those steps. Based on the above points, you'll be able to identify at least some spots where your playbooks are lacking, or where configuration changes are required in your systems or permissions that allow responders to complete the required tasks in the playbook. When an actual incident occurs, because the resolution steps will have been rehearsed, responders will be more confident in executing the playbook and be able to focus more on responding to the incident and less on trying to decipher what is being asked of them by the playbook and why. Here are some questions that are likely to get answered when you test your plans. Are the right metrics, logs, and alerts listed that will allow responders to establish beyond reasonable doubt that this is not a false positive? Do the metrics and alerts generated allow responders to identify which assets/resources could be involved in the incident and which applications those assets support? Do responders actually have the right permissions to access firstly the metrics and logs that they need, and secondly the resources that are involved in the incident? Are the right stakeholders engaged during the incident at the right level of technical depth? Think about what a C-level needs to hear, as opposed to what public relations needs to hear, as opposed to what the application's developers need to hear. Our third phase is continuous improvement. At a bare minimum, you need a mechanism that allows you to take your outputs from your testing, such as failure points, and feed those into a processor's inputs to rectify the defect, and then conduct the test again. That mechanism may include tools such as ticketing systems for tracking defects to resolution, but the mechanism itself is a closed loop that is triggered by inputs and produces an output. Once the incident has been resolved, there is still some work to do. Reviewing what happened during your response gives you an opportunity to reflect and improve. Consider the following from a retrospective viewpoint. Did the incident response plan work as expected? Could responders follow the playbooks during the identification and resolution of the incident? Are any changes required to the playbooks to account for the actual response steps taken during the incident? Did responders have the permissions they needed to firstly complete the tasks outlined in the playbook, and secondly, to take any other actions not noted in the playbook required to resolve the incident? Now, back to our story. You want to know how that misconfigured launch template got associated to the auto-scaling group. CloudTrail will give you that information. It may have been a human, or it may have been a machine that called the API. Either way, it needs to be rectified. In other situations, there may even be additional steps that you want users or customers to take, such as resetting their passwords. The final phase I want to cover today is automation. The great thing about going through the three earlier phases I've outlined is that they can have the happy benefit of setting you up for the fourth. If you're able to clearly define what constitutes an incident, for example, an EC2 instance is put into production in a misconfigured state, and if you're able to clearly enumerate a set of steps that can be taken to deal with that incident, and those steps can be confidently performed without negative side effects, such as replacing the instance with a correctly configured one, then you have a great candidate for automation. And that's one less task that people need to get out of bed for, or spend time remediating during their ops shift. So with that, let's take a look at a demonstration with some low-level automation that can get you started, using AWS services and features that exist today. AWS has services that can get you started even with minimal automation. Let's go back to a simplified version of the architecture I showed you earlier. These parts all look familiar, but now I'm adding some components. I add an AWS config rule that checks EC2 instances to see which army they were launched with. Then I create a rule in Amazon EventBridge that will capture non-compliance events sent from my AWS config rule. Amazon EventBridge is a serverless event bus service that you can use to connect your applications with data from a variety of sources. Amazon EventBridge receives the event and consequently triggers some actions. In my case, it triggers the creation of an incident in AWS Systems Manager Incident Manager. Incident Manager is an incident management console designed to help users mitigate and recover from incidents affecting their AWS hosted applications. Now that I have got an incident open in Incident Manager, I can do a lot of cool things. The service page is in my responders, who need to then check into the incident. I can also have the service send incident updates into a chat tool, such as Amazon Chime or Slack, so that responders and other stakeholders working in those rooms or channels see automated updates on the incident. I can easily perform that integration using AWS Chatbot. In the demonstration I'm about to show you, I now have a live incident on my hands. I will show you how to work with Incident Manager from the point of view of the incident responder. I go to the AWS Systems Manager Incident Manager console. And then I select Response Plans. You can see I've created 2 response plans, and today's incident has triggered the Non-Approved Army's response plan. A response plan is a plan that you create to respond to an incident. It includes who to engage, where to send updates, and the steps to be taken to resolve the incident, with this last part in the form of a runbook, with templates available to do this in Systems Manager documents. I now go to the Incident Manager view, and I can see that there is an incident open. Selecting that incident, I immediately see some very useful information in the summary section for the incident, including the resource ID, the AWS region, and the AWS account ID of the impacted resource, and the config name of the config rule that triggered the incident. As a responder, I've been alerted to this incident by email and SMS. I need to acknowledge that I have been alerted and that I am starting to work on the incident. I click on the Engagements tab, I locate my name and select it using the radio button. I click Acknowledge, enter the code that I've received via email, and click Acknowledge again. I can see the Acknowledged column has now changed to Yes. Now, I go to the Runbooks tab and start working on this incident. I'll set the page to refresh every 10 seconds. Firstly, in Step 1, Triage, I am directed to review relevant metrics such as HTTP 4XX and 5XX return codes. I'm also guided to update the incident if necessary in the Communicate Customer Impact section. Once I've completed those tasks, I click Resume to move on to the next section. At Step 2, Diagnosis, I again received customized and very contextual instructions helping me to locate the cause of the fault, including checking the config rule name, compliance status, and resource ID of the impacted resource. To do that, I go back to the Overview tab and then Summary, noting that information. Remember that I have customized this runbook to suit the exact requirements of this incident type. I'll now return to the Runbooks tab, having completed those steps. I then review and undertake the remaining steps in Locate Failures. Once I've completed all those tasks, I will again click Resume to move on to the next step. And you can see, as I do this, the status for each step changes from waiting to success, and we can see that diagnosis has just changed right now. At Step 3, Mitigation, I review the instructions required to mitigate this incident. First, the pre-mitigation items such as notifying stakeholders and preparing emergency change request. I then perform the mitigation as instructed. To do that, I go to the Config console and locate the relevant rule that I took note of from the summary. I go to Rules and then I'm going to locate the rule that I took note of, approved armies by tag. I select that rule and then go to resources in scope. And indeed, I find the instance in the list of non-compliant resources. As per the instructions in the runbook, I select its radio button and then click Remediate. I see the status column for that resource change to action execution queued. This particular remediation action will terminate the EC2 instance. After a minute or so, when I refresh the resources in scope list, I can see the status has changed again to action executed successfully. By the way, I've configured this response plan to send updates to a chime room that our response team uses to manage incidents. You can see here that Incident Manager helpfully sends updates to the chime room that myself and my colleagues are working in. You can also configure this integration to work with some other communication tools. I configured this using AWS Chatbot. I return to Incident Manager to complete the recovery step. I first go to the Open Incident and again select the Runbooks tab. I then go to the mitigation step, having just completed that step successfully in AWS Config. I again click Resume to complete that step. I finally move on to the recovery step, complete those instructions to verify that my mitigation was successful from the applications and users' viewpoints, and then finally click Resume. All steps of the runbook are now complete. Checking the status for the entire runbook now, I can see that the status column lists success for the runbook. I am satisfied that the incident is resolved, so I go ahead and click the Resolve Incident button and then the Resolve button on the confirmation dialog box. I can see now that the incident is resolved. Either now or at a later time, as part of my organization's continuous improvement activities, myself and other stakeholders involved in this incident will perform a retrospective. When that time comes, I will click Create Analysis and enter the necessary information and continuous improvement actions to be taken there. This concludes the demonstration. Alright, conclusion and action items. In conclusion, I've covered 4 high-level phases with you: plan and prepare, simulate and test, undertake continuous improvement and retrospective activities, and automate wherever possible. To get yourself started, please take a look at our AWS Security Incident Response Guide online. To get yourself started specifically with writing runbooks or playbooks, we have an online repository in AWS Samples named AWS Incident Response Playbooks that you can download and use directly or customize to suit your needs. You can also customize them for use with Incident Manager. Also, do check out our threat modeling blog post in the AWS Security blog. We encourage you to get engaged with our training and certification content today. You got this. Thank you very much for watching this. I hope you've obtained some actionable knowledge from it. We do value and act on your feedback. Please do take a moment to complete the session survey.